Hey guys, so in this video here, we're going to be talking about piecewise functions. So to start us off, let's check out our warm-up here. It asks us to evaluate the function for the given value of x. So we're given this function and we want to know if we plug in some sort of x value, what is going to be the output or what is going to be the y value. So if for part A, it's asking us when x is equal to 4, what is your output? So what we have to do is understand that whenever we're given an f of x notation, that is saying we got to plug in some sort of x value. We got to plug that into our function and we'll get some sort of output. Or usually we can think of this as the y value. So let's go ahead and set that up here for x equals 4. So we're going to plug this 4 in for f. And so that's what it's going to look like when it's set up. And then writing the 4 wherever x is located. So that's where x was, so I'm replacing that with a 4. And then working this out. So order of operation, got to multiply first. So 8 minus 3 gives me 5. So my answer here is 5. So when x is 4, my function output is 5, or my y value here is 5. Now, when I see something like this is saying I'm going to be plugging in -5 in for x. So that is my x value that I'm working with. So my setup, if I were to work this out, is going to be 2 times -5. Instead of this x, it's a -5 minus 3. And if I work this out, -10 minus 3 gives me -13 as my answer. Since I multiplied the 2 and the -5, got the -10, brought down the -3, and combined them and got -13. Okay, let's kind of summarize what we just did here. So all I'm asking you to do is to take whatever x value they give you, plug it into your function, and get out your output or your y value. So to kind of summarize things for a moment, what a lot of Algebra 2 students will start to realize is anytime you have an f of x, so in this case, f of x equals 2x plus 1, it is the same way to say y is equal to 2x plus 1. The reason that sometimes we favor this type of notation, writing f of x instead of y, is because you can see what you're plugging in, whereas for y, there's not like a parentheses here to help us see, oh, we're going to plug in this number for x. So sometimes we favor this type of notation rather than writing as y equals. So anytime you see f of x, just remember that's another way we can write y. All right, let's get started with today's definition here, which is piecewise function. Just like the way it sounds, a piecewise function is a function made up of two or more equation. That should say equation. I have no idea why that says questions. I'll fix that. So there we go. So here's an example of a piecewise function. You can see that here is f of x. So again, that is like your y. And when you look at the equation, there is one line here and then another line. Well, each line represents an equation. This line is 3x plus 2. So that's the first equation. And here is the second equation as 1/2 x plus 1. So there are two equations here. And what I also want you to notice is that this side here is inequalities. So those inequalities help us test which equation to use. So you might have noticed that here in the second sentence, it says the input or the x value determines which equation to use. So depending on what number you're plugging in, this will determine which equation to use. So if your x, in this case, is less than -2, then that means you have to plug it into this equation. Whereas if your x is greater than or equal to -2, then that means you have to plug it into the second equation. So let's take a look at this f4. So this is saying, here's my x, and my x here is 4. Well, first off, you need to look at the right-hand side of the piecewise function and test out which equation you have to use based on the inequality. So if x is equal to 4, well, 4 is bigger than negative 2, so I have to use the second equation. So here I go using the second equation. Let me put a 2 here just so I remember which equation I used. So if I'm plugging this 4 into the second equation, this is going to be 1/2 4 plus 1, and then I could work this out. Now, I do have a fraction here, but anytime you want to multiply a fraction, just put the whole number over 1 and then try to multiply. So in this case, if I put 4 over 1, I can multiply straight across. So 4 times 1 is 4. 2 times 1 is 2. And 4 over 2 is 2. If I bring down the 1 and add, this is going to be 3. And that is my answer. In the next one here, we have f negative 2. So here's our x, and when x is equal to negative 2, which inequality would we have to use? Well, in this case, we have to use this one here, because this one is the only one that says x can be equal because of that line there. So x can be equal to negative 2. So I'd have to choose this one and not this one, because this one doesn't have the equal sign. So again, I'm using the second equation. So I'll put a little 2 there just to remind me which equation I'm using. You don't have to do that. I just prefer to do that. So in this case, again, I'm multiplying a whole number with a fraction. So I'm going to change that whole number into a fraction form by putting it over 1 and then multiplying straight across, because that's how we multiply fractions. So negative 2 over 2, if I multiply. And so bring down the positive 1. Now, negative 2 over positive 2 is negative 1. And so negative 1 plus 1 is 0. I guess my answer is 0. But that's it. So let's take a look at C here. So for C, we have negative 5. So when x is equal to negative 5, that means that x would be less than negative 2, because negative 5 is definitely less than negative 2. So I'm going to be using the first equation. So here I go. I'm going to plug in my negative 5 into the 3x plus 2. Work this out. So 3 times negative 5 is negative 15 plus 2. So they're opposite signs, so you want to subtract from each other. So that gives me 13. But it's a negative 13 because the 15 has more negative. All right, and then that's it. So in the next video, I'll show you a few more examples and even show you what a piecewise function would look like on a graph.